The Extended Phenotype by Richard Dawkins, Review and Scientific Critique. In The Extended Phenotype, Richard Dawkins builds upon his earlier work in The Selfish Gene, extending the gene-centered view of evolution by proposing that the influence of genes reaches beyond the organism itself, impacting the environment and other organisms. Dawkins argues that genes drive not only the behavior and physical traits of the organism, but also create structures and influence interactions that enhance their own survival, even outside the organism's body. However, this gene-centered framework fails to address several scientific defeaters, particularly regarding the origins of complex specified functional information, irreducibly complex systems, orphan genes and proteins, and higher-level taxa. These features indicate that an intelligent cause, rather than random mutation and selection, is necessary to account for life's complexity. 1. Central thesis and the concept of the extended phenotype. Dawkins's central thesis is that genes act as selfish agents whose influence extends beyond the organism to its environment. He uses examples such as spiderwebs, beaver dams, and parasite-induced behaviors to argue that genes affect not only the organism's immediate phenotype, but also its extended environment. Dawkins suggests that this extended influence is merely an extension of the gene's role in shaping the organism, claiming that natural selection acts on these external structures as it would on body parts. While this view provides a new way of considering gene-environment interactions, it relies heavily on the unjustified assumption that random mutation and natural selection can produce all the necessary complex functional information. 2. Limitations of micro and low-level macroevolution in explaining complexity. Dawkins' model, while effective at describing microevolution and low-level macroevolution, does not address the requirements of higher-level organization, particularly in the context of naturalistic mega-evolution. Evidence supports microevolution, which involves adaptations within a species' genus family level, and low-level macroevolution, or speciation within a genus, through random mutation and natural selection. However, Dawkins extends these mechanisms to explain all biological complexity, including the rise of new phyla, classes, and orders, despite the absence of empirical evidence supporting such a vast extrapolation. And in fact, in the presence of falsifying evidence against the gene-centric view, as we have discussed in other videos, limits of micro and low-level macroevolutionary mechanisms. In observed examples, microevolution often results in minor modifications to existing structures, while low-level macroevolution within genera occurs through variations within a set genetic framework inside a species, genus, taxonomic family. These processes involve adaptive changes, including loss-of-function mutations, which offer immediate and short-term survival benefits without creating novel structures. By contrast, the creation of higher taxa, such as new phyla or classes, require new, functionally integrated structures and pathways that exceed the capabilities of random mutation and selection alone. 3. The problem of complex specified functional information. Dawkins' gene-centered model does not empirically explain, with step-by-step testable and falsifiable biochemical pathways, the origin of complex specified functional information, which is necessary for the intricate biological systems observed across all levels of life. Complex specified functional information refers to highly ordered sequences or structures that fulfill specific, interdependent functions within a system. Such information is present not only in individual genes, but also in the coordinated relationships among proteins, pathways, and cellular processes. Insufficiency of random mutation in generating specified functional information. Random mutations, while capable of modifying existing structures, cannot produce entirely new, complex functional information. Beneficial mutations involve minor changes or losses within an existing framework, rather than the creation of new interdependent systems. Specified functional information, like that required to produce molecular machines or complex regulatory networks, involves intricate relationships among parts that cannot be accounted for by random, uncoordinated changes. Dawkins' model does not address how such specific, interdependent complexity arise through undirected mutation and selection. Intelligent design as a source of specified functional information, specified complexity, similar to coded language or engineered systems, indicates purposeful arrangement. Intelligent design posits that the information-rich structures in biological systems reflect an intentional cause, one that aligns with observed patterns of functional information in other contexts. Dawkins' exclusion of this reality limits his framework's explanatory power, as random mutation and selection do not provide an empirically possible, step-by-step, testable, and falsifiable biochemical pathway for the generation of specified information required for life's complexity. 4. Failure to address irreducibly complex systems. Dawkins does not solve the problem of irreducible complexity, which poses a defeater to his extended phenotype model. Irreducible complexity describes systems that require multiple, interdependent components to function, where the removal of any part renders the system inoperative. Examples include cellular structures like the bacterial flagellum and the blood-clotting cascade, both of which require the precise coordination of multiple parts. Challenges of stepwise selection in irreducibly complex systems. For irreducibly complex systems, random mutations would need to produce each necessary component to be present at the same time and same location in a given creature to achieve functionality. Dawkins proposes that parts of such systems could evolve independently and be repurposed, but this hypothesis lacks empirical demonstration and empirical evidence. The probabilistic defeater of producing each part of a complex system in a manner that leads to functionality without intermediate advantages is empirically impossibly high. Dawkins' gene-centered approach does not address how random mutations could produce the multiple, integrated components required for irreducible systems, indicating a defeater against his model. 5. Orphan genes and orphan proteins. Orphan genes and orphan proteins, unique genes and proteins that have no known homologs in other species, present a falsifier to Dawkins' theory. These genes and proteins appear in specific lineages and serve unique functions, without any homologs or evolutionary precursors. Their sudden appearance is impossible to explain, with an empirically demonstrated step-by-step viable, functional, gradualistic biochemical pathway, within a framework that relies on gradual accumulation of mutations from shared ancestral genes. Inadequate explanation for the emergence of orphan genes and proteins. Orphan genes do not exhibit evolutionary ancestry, yet they play essential roles in the organisms in which they are found. Dawkins' model, which posits that random mutations build upon existing genes over time, does not provide a testable and falsifiable biochemical pathway for the origin of entirely new, functional genetic sequences. The existence of orphan genes and proteins shows that random mutation and selection cannot account for all genetic information, pointing instead to an intentional, information-rich origin as proposed by intelligent design. 6. No step-by-step pathway for the formation of irreducible complexity and specified functional information. Dawkins' model does not provide a step-by-step, testable, and falsifiable biochemical pathway for the formation of irreducibly complex systems or the generation of specified functional information. Scientific inquiry requires that proposed mechanisms be testable, observable, and falsifiable. However, the scientific literature lacks documented experimental evidence of functionally irreducible systems arising from random mutation and selection alone. Dawkins' gene-centered approach does not address how such complexity could emerge without directed input, as there are no experimental or observational demonstrations showing the gradual formation of irreducible systems or specified functional information from undirected processes. Absence of experimental evidence for naturalistic mega-evolution. The formation of complex biological structures and specified information necessary for higher taxa has not been documented through stepwise, undirected processes. Empirical research supports microevolution and low-level speciation within a limited framework, inside a genus and taxonomic family, but does not substantiate the claim that random mutations can create the level of complexity observed in higher taxa. Intelligent design, on the other hand, provides a viable scientific explanation, positing that complex, information-rich structures are best explained by intentional causation. 7. Philosophical bias against intelligent design. Dawkins' exclusion of intelligent design reflects a philosophical bias rather than a strictly scientific position. His commitment to materialism leads him to dismiss the reality of design without fully engaging with the scientific challenges it addresses. By assuming that all biological complexity must be explained by undirected processes, Dawkins precludes a legitimate scientific hypothesis from consideration: intelligent design as a scientific framework for biological complexity. Intelligent design is not inherently unscientific. Rather, it proposes that certain features of life indicate design. Much like other scientific theories, infer causation based on observed patterns. By analyzing characteristics such as specified complexity, irreducible systems, and unique genetic information, intelligent design offers an alternative framework for explaining the origins of biological complexity. Dawkins's a priori rejection of design limits the scope of his analysis, resulting in an incomplete understanding of biological evidence. Conclusion: the extended phenotype offers a reductionistic perspective on how genes might influence organisms and their environments, broadening the discussion on evolutionary theory. However, Dawkins' reliance on random mutation and selection as sufficient explanations for all biological complexity does not align with empirical evidence on the limits of these processes. While his model may explain microevolution and low-level speciation within limited taxonomic family boundaries, it falls short of accounting for the origins of complex specified functional information, irreducible systems, orphan genes, and the emergence of higher taxa, such as kingdom, phylum, class, order. Dawkins' philosophical commitment to materialism prevents him from considering intelligent design, a scientific hypothesis that addresses the origins of life's complexity with a focus on specified information and purposeful organization. Incorporating intelligent design as a viable explanation would allow for a more comprehensive approach to understanding the origins of biological complexity, one that goes beyond the constraints of Dawkins' reductionist, gene-centered view. Thanks for watching. Please like, share, and subscribe. And comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a Level 1 comment directly below the video. I will respond to all polite Level 1 comments, even if it takes me a while due to other commitments.